This is Professor Sampson, and today we're going to solve systems by graphing. Alright, we're going to solve systems by graphing. What systems means that we have two equations that we're looking to find out where they meet or if they meet. So I have my equations here. The best way to do that on my MATLAB, and I have regular graph paper here, but the best way to do that is to rearrange your equations in y equals. Remember, our graphing calculator, you can't see it right here, but has a y equals button. So if we can rearrange our equations to say y equals, then we can use our calculators to find our points. So we don't have to go around guessing points. So for example, this first equation here, I'm going to write down here, is x minus y is equal to 2. Now, x minus y is equal to 2. I want to get that to say y equals. Basically, I want to get this y by itself so that it says y equals. Well, the first thing I have to do is move the thing that is not attached to this y. So I'm going to subtract x from both sides. When I do that, I get a negative y, don't forget your negative, is equal to 2 minus x. Right? And I can't have a negative y. There's no negative y button. So to get rid of this negative, we're either going to multiply through by -1 or divide by -1. Either way, what we're doing is getting rid of the negative, and that's going to change the sign. So I divide everything by -1. So of course, -1 divided by -1 will leave you with the y is equal to 2 divided by -1 is -2. In front of the x, there's always a number, which is that -1 divided by -1 is 1, positive 1, so that's plus x. Remember, all it does is change all the signs. So now you have an equation that you can put in your calculator. Alright? So, this is your equation here. Now, you can do one or two things. You can put this equation into your calculator and graph it, or if you know y equals mx plus b, you can put down b and then use your rise over your run. But if you're using my MATLAB, it's easier for you to put this equation in your calculator and get 2 points, which I'm going to do. Y equals -2 plus x. I'm going to go to my y equals. I'm going to put in -2 plus x. When I do that, I'm going to hit second and table so I can get me some points. As you can see, or I'm going to write it down, I have a point 20. Going to put it over here. 20 is one of my points, and then I have another point 31. So in my MATLAB, you would plot both of these points. Using my MATLAB, you would plot 20. That was the middle, sorry. And then I'm going to go over 20. Uh-oh, can't see. I should have made my lines darker. Yeah, this is my axis here. Okay. So now I'm going to plot the point 20, and you'll do this better on my MATLAB. Right? And then I'm going to plot the point 31. So those are my points. And my MATLAB will connect it for you, but since I'm doing it on paper, of course I have to use a ruler and connect it myself. Okay? So, there's my first line that I graphed on paper. And I'm going to do the same thing with my other equation, x plus y is equal to -4. I'm going to subtract my x from both sides. I'm going to get y is equal to -4 minus x. I'm going to put that in my calculator. Now I just left my old one in there. I can either leave it or delete it, but I'm just going to go around and type my new one, -4 minus x. Now the reason I want to do that, I want you to see. Alright, see in my calculator, remember this was my first point, x, there's my 20, and there's my 31. That was for my first line. Now I'll put in my second line, I'm going to have to use this x and that y. Alright, so I'm going to use this x and that y because that's my second equation. If you look at my y equals, this is my second equation, so I have to use my second table, y. Alright, so if I use this, I can use 0 and negative 4 as one of my points. And then I can use 1 and negative 5 as another point. Alright, so I'm going to put that on my graph paper. 0, negative 4. Alright, and then 1 and negative 5, which is right there. And then my math lab will connect the lines for you. But I'm again going to use a ruler to connect mine because I'm graphing by hand and not using my math lab. Okay. Alright. So again, that's how you graph. You rearrange it into y equals, and then you put it in your calculator, and the calculator will give you 2 points, or you select 2 points from there. The reason you don't want to keep guessing points is because sometimes you'll actually guess a fraction, and then you have to keep guessing and keep guessing and keep guessing. Alright? So the last part of it will be asking you where they meet at. Alright, where do these points meet at? That'll be the last question. So the last question will be where they meet at. Now mine doesn't meet exactly where it should because I drew it later, but you'll be able to see where they meet. You can also see where they meet in your calculator because you'll see that they'll have the same point. So negative 1, negative 3, alright, is where those two graphs will meet at. Of course, my lines weren't straight, but that's where they'll meet at, negative 1, negative 3. It's a little bit off. It should be right here, but that's because I didn't take my time in graphing, alright? So negative 1, negative 3 will be the question that they ask you on where they meet, alright? So just make sure that all you do is you rearrange each equation. If you rearrange the equation and then put them in as y equals, then you won't have a problem trying to find out trying to get the answer to your systems. If you do it any other way, you might have difficulty doing it. Let's do one more. So this one, my two equations are going to be 2x plus y equals negative 4 and 5x minus y equals negative 3. Alright, so those are my two equations that I'm going to graph. Again, I'm going to go back to the bottom where I was, right? And then I'm going to rewrite it. 2x plus y is equal to negative 4. I need the y by itself, so I'm just going to subtract 2x from both sides, leaving me with y equals negative 4 minus 2x. Right. I'm going to put that in my calculator. Alright, I'm putting in negative 4 minus 2x. And then I'm going to go to my table and get myself, I graphed it, but I'm going to go to my table and get myself 2 points. In this case, I'm going to use negative 2 and 0, and then negative 1 and negative 2. Alright, because my graph paper is hard to see, I'm just redrawing my axis so I can make sure that I know where I'm graphing these things at. So those are my axes. So now my first point is going to be negative 2, 0. All right, hopefully you remember. You go over negative 2 and put a dot on negative 2, 0. You only click one time. And then my other point is negative 1, negative 2. Go over to negative 1, down to negative 2. Alright, and then my MATLAB would connect it, but I'm going to have to connect mine on my own because I'm doing it by hand. Okay, so that takes care of that one. My next one, I'm going to do the same thing. I'm going to rearrange this one. Got 5x minus y is equal to negative 3. Subtract 5x from both sides. Negative y is equal to negative 3 minus 5x. Like we said before, we're going to divide everything through by negative 1, which just changes the sign. So this is going to become y. That's going to become a positive 3, right, or just the 3. And this is going to become plus 5x. Dividing through by negative 1 changes all the signs. This is my other equation, y equals 3 plus 5x. Going to put it in my calculator. 3 plus 5x. 3 plus 5x. Going to go to my table. Look at my table. I'm going to be comparing this first row to this last row. And so now I have a 0, 3 for this one. And I also have a negative 1, 1, 8 for that. Alright, so I'm going to do it again. 0, 3. Right, 0, 3. Right there. And then 1, 8. Alright. I did 0, 3 and 1, 8 right there, and my MATLAB would draw it for you, but again, since I'm doing all my work by hand, okay, so there I go. There's my problem, and that's the end of graphing it. The next question my MATLAB will ask you is where do they meet at? And I can see right here they meet at negative 1, negative 2. And then if I wanted to check that out, I would look in here and I see that negative 1, negative 2 is on both of the graphs. Okay? So hopefully that makes sense in how you're going to graph and how you're going to solve systems by graphing.